will be on Blackboard. Okay. And then essentially it's just going through different examples of triangles and circles with this. Okay. So the first example that you guys did in Dino, and I'm just gonna go through those examples instead of going through new ones and stuff. So we have to find the hydrostatic force of a triangle completely submerged. So it's one distance from the sea level, its height is 2, and its base is 3. So essentially the first thing that you should do is write down the formula, which is F equal to the integral from A to B of WHLTH. Okay. The next thing to do is get L in terms of H's. So then we have to do similar triangles. As we get deeper and deeper by measuring the force, L changes, and so does H. As we get deeper and deeper, height increases. So then the height is always, in this case, 3 minus H. Okay? Any questions on that? So then we can set up the relationship of L over 3 minus H equal to 3 over 2. You guys understand this? So then L is equal to 3/2 times 3 minus H. After that, you just substitute that for L and you solve. So then in the end, it would be 3/2 W from 1 to 3, 3 minus H times H. Are you guys good with this problem? Yeah. Are you talking about, you said A, right? It's from the top height to the bottom height. Because your height is increasing downward. Yeah.
So if the triangle is split and a point is on top, would your H be H minus 3?
It would always start at the top. So if your triangle is like that, this would still be your A value, this would still be your B value, and then these would remain the same because you're still going down like this.
So you still have like something minus H?
Yeah,
okay.
In this case. Yeah.
Would it not be that way?
We'll get through them, but you should try to like understand it because H is increasing, so then the distance that we're actually, the height that we're actually looking should be going down. So then it's going towards the bottom and the triangle is becoming smaller, essentially. Good? So I'm going to erase it now. So now we get to a triangle where part of it is submerged and part of it is still on top. So that's one on top and one on bottom. So half of it is under. So in this case, H is still going downward. Okay. So then the triangle that we'd be making, so we'd be using the top part as part of the similar triangle. So then the top part is 1 plus h. So as h goes downward, we'd be making a bigger triangle. So this time it'd be 1 plus h. Okay? So then we rewrite the formula. So L would be the base that's changing. So L is equal, or L over 1 plus h equal to the base 3 over 2. This is with similar triangle, so then L is equal to 3 halves times 1 plus h. Any questions on that? This time it's 1 plus h because when we did the similar triangles, the h that we're looking for goes from the top all the way to our L, and that includes 1 plus how much distance we're going down, so it's 1 plus h that time. So then we have an equation of L in terms of h, so we just substitute that in and solve. So then this would be, we have going from, now this time, this would be 0. It's going from 0 to 1, because we're only interested in the submerged part. W would be outside. You have h squared plus h. Yeah. Do you have questions on that? So essentially, it's very simple once you understand this is the only formula that you need to know, and you need to do similar triangles to get L in terms of h. And it's just substitution. With circles, it's sort of the same thing, except you don't use, you have to use the Pythagorean theorem to get L in terms of h. Yeah, I will go through everyone, but do you guys understand this right now? So now we look at trapezoids. It is 4 feet submerged. Its height is 6 feet. The top base is 6, and the bottom is 8. It doesn't matter what shape you have. All you have, your main goal should right now be to try to get L in terms of h. Okay? So then you need to figure out some way to get that equation. The way they teach you is that you draw similar triangles or a triangle by making this into a parallelogram. Okay? And then you have to write down your equation. So this entire length, say, is L. Okay? So this entire length is L. This tiny part, when we're looking at the triangle only, would be L minus 6. Because that would be the length cut out from the top face. Okay? If we start our height at sea level and it goes downward, then the height, what would it be? You guys want to guess? H minus 4. This time. It would be H minus 4 because, did I draw it right? Yeah, essentially, the more down we go, we are only interested in this part, right? So if this entire length is H, we take out the 4, and that's the height we're looking for. So this distance would be H minus 4. Okay, so it's the distance from the top to the length that we're interested in. You guys want me to say that again? Okay. So looking at the length first, length is equal to the entire distance across from one side to the other. When we take away the 6, we get L minus 6. Like in the other triangles, the height that we were interested in was from the top surface to the L that we're looking at. That distance, if we're going down directly from sea level to that point, that entire distance would be H. If we take away 4 from it, the distance that we're looking at, the height that we want, is H minus 4. Yeah? Everyone say yes? Yeah.
So why is it H minus 4?
Because H is the bigger part, and we're looking in this section. So it's like this entire level that we're down is H. We're only interested in this part because that's the height we're looking at, and this part is 4. To get this height, this would be H minus 4.
Okay, so like your other examples, H would be small.
Like when we did with the triangle, this was our length, so we wanted from the top to L, and say this was 1. And H is always from sea level to the point. So in this case, we wanted this entire distance, so it was 1 plus H. Okay? All right. Are you guys still very confused on that?
Like with the triangle submerged problem, okay, yeah, I understand that you're supposed to do 3 minus H on that, but like let's have one important use. I'm trying to figure out like why this one's different. Like
I'll draw the triangle submerged again. Yep. So with the triangle submerged, this entire length we knew, and it was 3. Okay? We were interested in from the top to say L. So we came down an H amount of distance. But sorry, H is always starting at sea level. Okay? So we did 3 minus H because in this problem, this triangle was upside down, essentially. We wanted the distance from here to the top. So then this distance would be 3 minus H. Because this is 3, we're not interested in this height. We're interested in the bottom height. Yeah, I should have said that. But it depends on the way the triangle is drawn.
There we go. Thank you.
Yeah. In this, the triangle, the top pointy part is on top, and we go to L. Okay? Yeah.
They never told us.
Because if we try to do a similar triangle and we get this height, this is not the shape we want. That's a trapezoid. Okay? We need a triangle compared to a triangle. And then if this triangle was drawn the other way, we would want this height. Okay? And then if this was 3, we would know that this is like 1 up there. So this would be 2. So then we do H, 2 minus H in this problem. to get that. Did I draw that? No, H would be all the way from the top, actually. Yeah.
It's 3 minus.
Yes.
Yeah.
Huh? That part would be 2 minus H. Minus 1. So it would actually be 1 minus H, wouldn't
It'd be H minus 1.
Yeah, H minus 1.
it? There you go. As you can see, I'm not an expert on this either. But did you guys see how we got H minus 1 on that? Because we just figured it out. All right. Let me explain this to you guys. The distance from the top to L is H. Okay? We're only interested in the distance from the top of the triangle to L. Okay? H is the entire distance from sea level to that L. 1 is the distance that we don't want, so it would be H minus 1. Okay?
Thank you.
Yeah. So, yeah.
That's a general rule. If the distance from H equals 0 to your little horizontal bar, is that always H?
Yeah. And then you work your way around it with the values you're given. So, do you guys want me to explain it again? Or no? Are you guys good?
Instead, you would have the traffic.
Then you would need to do H from the bottom up. You need to find that height, essentially, to compare. Does that make sense? Okay. So, finishing this problem up, we have L minus 6 all over H minus 4. Now we have to equal it to the triangle that we're comparing it to. If 6 is at the top, then this distance would be 6. The base of the triangle would be a 2. So then L minus 6, that's comparable to a 2. And then height is comparable to 6. So then you get your equation for L. Okay? So L minus, or let's just say L is equal to 1/3 times H minus 4 plus 6. And then you just plug that in here. What would your A and B values be for this problem? 4 to 10? Because the height the trapezoid starts at is 4. It goes all the way down to 10. So this would be from 4 to 10 times W times 8 times that entire thing. And then you will have to solve it. Any questions on this? Yeah. Yep. What do you mean? You have to split it into 2 triangles? I will need to see that problem. But I can pretty much say this with a guarantee, you won't need to split anything into 2 triangles on the test. So, are you guys good with this? Yes? So we'll move on to circles now. So, all right, guys, we have a half circle submerged in, yeah, and you have to find the hydrostatic forces. Its radius is 4. First thing you guys should always write down is the equation. Force is equal to, from A to B, WHLDH. And then again, we have to find L in terms of H. Okay, so our length would be from the two ends meeting. Okay, so essentially in this, we have to use the Pythagorean theorem. The distance from the middle of the circle to L, that would be our height, because the circle is submerged. So it'd be H equal to 0 to H, okay? From sea level to our L. Our radius is a 4. So when we write down the equation of Pythagorean equation, we have, if this entire thing is L, then the length that we want would be just L over 2. Okay? So we have a triangle L over 2 squared plus H squared equal to 14, or sorry, 16. So L is equal to 2 times the square root of 16 minus H squared. And once you have that equation, the hard part is done. You just substitute that in for L and you solve it. Your A and B values would be from 0 to 4. Are you guys good with that? So we did the same thing again, just with the circle. We found L in terms of H, but this time we needed to use the Pythagorean theorem. Are you guys good with that? So we can move on to the plates thing.
Will they ever have us just set up here or we don't?
Mostly it'll be solving. For this exam, it will be solving. On the final, it may be just quickly set it up, but. Okay, so this one is, the most simple problem is if you have a plate that's just horizontal flat and you know the height is 8, okay, then force is equal to pressure times area, okay. Pressure is W times H, and then area is 25 in this case, so 5 squared. And we know height is 8, so we just plug that in. So 200 W. Now, it's important to see the process. So then we kind of replicate that same thing. Although that one was really easy. In this, since it's completely flat, the height never changes, so we can do it without an integral. But if we have something that is vertical, so in this case, we have an L value and an h value. But since it is a perfect square, the L value doesn't change. It'll always be a 5. So we can set it up. F is equal to, it goes from 3 to 8. W times 5 times H times DH. So for this one, again, we use the same thing, WH times area, but H changes, so we needed an integral. So now we can do a tilt problem. And I'll erase all of this. And if you haven't signed in, make sure you come up and sign in at the end or when you're about to leave. Okay. So we have a plate that's at an angle of 45. It is a 5 by 5. And then the distance all the way to the bottom is 8. Okay? In this, or DL, or sorry, or L value, or what do they say? They use DS, yeah. L is still 5, but the instead of L, we're interested in DS essentially. So this is our DS value. This would be our DH value. So it's a mini triangle. If the distance to the entirely to the bottom is y, see they use, there's like lowercase h's and uppercase h's, so it can get a bit confusing. Essentially, so the first thing that you do is, and the best thing that I can say is, you just do what they do, okay? To get things in terms of other, like we found L in terms of H, we need to find DH and DS and H and S essentially, okay? So let's just go with it. Sine of 45 is equal to DH over DS. Okay? So if this tiny angle is 45, this is DH, that's the hypotenuse is DS. So we have DH over DS. Okay? And then they labeled the height from the bottom to our DS as a capital H. So then the height from the top to the H is A minus H. So then in this triangle relationship, the height is H. So then when we do sine of 45, again, we have H over 5. because the entire length of this would be 5. So we can draw another triangle. They did that. This time they measured h from the bottom going to the top because they just wanted the height of the entire thing to be h and not mess with -3 or something from the top. Okay. So then, if h once the capital H was the entire value, then we would have a similar triangle that we use to get sine of 45 with h over 5. Okay. Are you guys good with that? Yeah. Is it going all the way to the top, or did they not? Yeah, they didn't draw it very clearly. Okay, I think it is actually, because that does work well with 5 more. Yeah. Okay, so now I will repeat what I did throughout the whole thing and try to make sense. Okay, so we have a tilt, right? We label the height that tilt goes to as capital H. Okay, not the length of it, because we know the length of the entire thing is 5, but the height that it goes to is h, and that changes depending on the angle. Okay, the distance from sea level to that height would be 8 minus h. Okay, so now looking at a relationship, if the height of the slanted surface is h, the length is 5, then we know that sine of 45 is h over 5. Okay? Looking at our tiny changes in element, we have dh and ds. ds is comparable to 5, and dh is comparable to h. Okay? So that triangle looks like that. Okay? So we have those two equations essentially. Now, looking at this top value, it's 8 minus h. Okay? We know from this that we have an equation we can solve for h. Okay? Sine of 45 is 1 over square root of 2. So h is equal to 5 times 1 over square root of 2. Okay? In this way, we have an equation or a value for h. With ds, ds is equal to dh divided by 1 over square root of 2. Okay? So then it would be square root of 2 dh. Did that all make sense? Or I'll say it again. We have an equation for h. We solve for h because sine of 45 is 1 over square root of 2. Okay? ds, we know sine of 45 is equal to 1 over square root of 2. We solve for ds, so we get square root of 2 times dh. Okay? Do you guys follow me on that? No. Okay. Then we have the equation force is equal to a to b WHLDH. since this is at a slant, when we do changes in element, they'll always be at a slant. So we'll need to make this into a ds. So force is equal to, it goes from the top to the bottom, right? The top, we labeled as 8 minus h. Okay, whatever that distance is. We have an h value. So essentially, our a value is 8 minus 5 over square root of 2. Okay? And then the plate, they told us at the very bottom, that's equal to an 8. Okay? Then we need a height value, or the h value that we, sorry, the length value. Did I say that right? Yeah. The length value they told us is 5. So we have 5 here. 5 times w. We multiply h by that. And then we need a ds. Oh, I wrote the equation wrong, sorry. The equation for slant is with a ds. Okay? We need it in terms of dh because we have height as a variable. We know what ds is square root of 2 times dh. So we do square root of 2 times dh. We switch out ds. I'll say that again. For slanted surfaces, this is the equation which you should memorize. It's not different from the other one, except instead of dh, we have ds. Okay? To find the ds component, we did sine of 45 of dh over ds. Okay? Now we know ds in terms of dh, and we made that substitution here. We knew the length value because they told us it was 5 wh times what ds is. The next part was finding a and b. We knew the b value always. We needed to find h, which we found was 5 over square root of 2. So then when we do 8 minus h, we get that tiny distance at the top, this tiny distance, and then we would know our a value. Okay? So all of this is essentially finding the parts for this equation. And that's the same with every hydrostatic force. Except when you do centrifuges, but almost like the same thing. Okay? Any questions on this? Are you guys just confused and don't care at this point? Yeah. On the practice exam, they don't have a slanted surface. So I would make sure that you guys understand this completely, because on the practice exam they don't. That doesn't necessarily mean that they won't have it on your exam. Okay. Oh, it could be a perfect quiz question. Yeah. Yeah. It's 5 by 5. So let's write down. So the first step, if you're given a slanted surface, okay, write down the equation sine of theta equal to dh over ds. Okay. Make sure you know your unit circle, so then you can do ds is equal to dh over sine of theta. they could give you a different, like they won't do this, but in case they give you this value as theta, okay, then just switch it to this value by doing 90 minus, or do cosine, but just switch it, do 90 minus that value. Because always go for this angle, the 45, where that is, okay? The second step, sine of theta is equal to h over your hypotenuse, which would be your L. Okay? Your A value is equal to, now I'm going to use a little h for your height going all the way from the sea level to the bottom of your surface. That's a good idea. All the way down to the bottom, we use d minus the total height of your slants. Okay? That gives you your A value. Your B value is always just all the way down, which is D in this case. Okay? So make sure you guys sign in at the very end. So then we have our integral from A to B. We know our W. We have H as a variable, our L value, and our D as we know what to substitute for it. Now, are you guys like somewhat relaxed with the slanted? So this should be like step 3 or something. Let us move on to a circle fully submerged. And all of this is on video for those of you who did come late. I can go over it once I'm done going through all the problems, but they will be on video. Okay. So we have a circle now. Or do you guys want to take like a 5-minute break? Keep going? Okay. So they tell us the radius of the circle is 4. We can make an element again. Our h will always be from sea level to that element. This entire length would be L. And they tell us the distance to the center is 10. Okay? If that distance is 10, when our h value is right at the top of the circle, h will equal a 6, because it would be 10 minus 6, and our y value, which is what they call from the center, will be a 4. So in this system, they label y equal to 0 when we are at the center. Okay? Do you guys all understand that? Y at the center is equal to 0, so y value all the way to the top is a 4. So when we do all the way to the bottom, y is equal to a -4. Since the distance from sea level to the center is a 10, and our h is always from sea level to our L, we're not going to go there yet. The height from the sea level to the top of the circle is a 6, because 6 plus 4, which is the radius, equals 10 to the center. Yes? So, let me redraw this actually. Wherever our height value is, say it is right there, our y value will be from the center, leading up to that height. Okay? So we get the equation h plus y equals to 10. Okay? And then y is equal to 10 minus 8. There are two ways of actually doing circles submerged. I always like to keep it h as my variable, so I can do dh, but you can change it to dy. Okay? But we're just going to go through with h right now, with dh. So y is equal to 10 minus h. If we were to find the distance from the sea level all the way to the bottom of the circle, what would it be? It'd be 14. Because 10 is to the center plus the radius, so the distance all the way to the bottom is 14. So once again, we write our equation from A to B, WHLBH. So we take out the W on the outside. Our height, or what would our A value be? 6. Our B value, 14. Times H. What would L be? 2x. Let me explain that. Okay. Yeah. So if this is our y value, our x value would be the length across, right? Okay. So then once again, we can do like a triangle. Okay. So x squared plus y squared equals to the radius squared. So we get x in terms of y now. Okay. And we already know y in terms of h. So we can just substitute that in. So L is equal to technically 2x. But we know what our x value is with y. So we do square root of 16 minus 10 minus h quantity squared dh. That would be doing it in terms of h. Okay? And that's the way I would prefer, but sometimes you can't solve it out. Yeah.
Isn't it just the same as you did twice as long? The first one is
Yeah, but you won't always. The point is that the first one, the center was at sea level. This one it changed. So you're saying just doubling what you get as a
Well,
value.
if you use that circle with the same radius, you can expand the integration.
Yeah, technically you can, but they would prefer that you do with a full circle. Although it would kind of be the same thing. If you just expand, but, well, that's the example. Yeah. You need to convert L into Y or H.
Like on the bottom you'll have like L halves equals square root of 16 minus y squared and then multiplied by 2.
It does come out. Does it come out to be the same thing?
Yeah.
Yeah.
Why do they make you?
They make you use X because they're trying to show you the XY coordinate system. But if you do L over 2, it's not. Yeah. Because the distance from the center to the outer circle would be an X value from both ways. So 2 times X is equal to L. But you could do L over 2 and solve it that way. I see for the exam, I don't think they will take off points if you do L over 2, but it's just something that the graders will not be looking for. Yeah.
If you do one with just a parabola that is a sentence.
What do you mean a parabola with?
So say a parabola starting at sea level of 8 that goes.
They wouldn't give you like a parabola because that would have its own equation.
Well, if they give you the equation, how do you just set that into
I would need to see a problem like that. But yeah, that'd be interesting. Any other questions? Yeah. Imagine this as the center. The circle would be like, oh, that's why they wanted to use X. There we go. So you should use X, let me just say that.
Oh, it's not a triangle.
Yeah, it's not a triangle going like that. Yeah. So let me just clarify. Do not use L over 2. Although it will work out for all the problems. Just use X. Yeah. So okay, this was so let me go over everything again. You have to find the distance going from the center to the top of the circle. Okay? You knew your 10 value, you knew your radius, so your A value would be 6. You just add that value to 10 to find your B value, which in this case is 14. Your H value plus Y equals to the value to the center, which is 10. So you can get Y in terms of H, so it's 10 minus H. Using similar triangles, we get x squared plus y, or not similar, Pythagorean theorem. We get x squared plus y squared equals radius squared. So we have now x in terms of y. And yes, the x thing still doesn't make sense, but just go with L equal to 2x, okay? And then substitute what you got for your x value into L, because technically your x value is there, not there. So, yeah. And then you just substitute everything in. So any questions on that? Yes.
So when you use L over 2, how do you know?
Use L over 2 when you have the triangles, right? Isn't that when we use them? Yeah. Yeah.
Do you like Taco Bell or tacos?
I haven't been to Taco Bell in a long time.
Okay. You're both kind of low.
Let me quickly show you how to do it with Y, although I don't use Y when I do it, okay? So we have 2x going off of that. We'll have 2w because we brought out the 2. Our a value would be, so in this case, we're going from 4 to a negative 4. This is using y instead of h. Okay? So if we're using y, we'd be going from 4 to a negative 4. That would be our a and b value. We need to find h in terms of y, which would be 10 minus y. That would be our h value. And then we'd have x, which would be 16 minus y squared dy. Because we're going from the top to the bottom. The top would be a 4, the bottom would be a negative 4. You could pull out a negative sign and make it a 4 to a negative 4. But I always just use the h way.
I
Yeah.
think I'm talking about negative dy or something like that, and then you put the angle like cancels out. Just trying to figure out where the negative.
Did they do a negative dy? Okay, I don't have it in my notes, but did they make this sign a negative?
Yeah.
Okay. So I don't have that in my notes, but it all depends on the coordinate system that you use, essentially, whether you're going up is positive or going down is positive. So in class, if they did this, then, negative dy, this allows it to be flipped, going from a negative 4 to a 4, and then you still get a positive answer. Any questions on this problem? So now we can go to centroids. Centroids are actually way easier than all of this. Because it's good to know how to do everything. Because there will be shapes where you will never know where the centroid is. Like, we're just using triangles and squares, but essentially, and circles. You could have shapes where you have no idea. And except for like computer engineers, this will come back. Like, all right. So say we have a triangle submerged. Now this is like the very first problem that we might have done. Okay. So this distance is 1. This distance is 2. That is a 3. So one thing that you need to know, the centroid is 1/3 from the base. So 1/3 of the way down would be our centroid in this triangle. Okay. So if we're trying to find 1/3 the way down, so it'd be 2 times 1/3. So we get 2/3 going down from the base. And that's just looking at the triangle though. Our value of the centroid, the height of the centroid, would be 1 plus 2/3. And that would be 5/3. Okay. The formula with centroid is W times height of centroid times area. That is equal to W, in this case, times 5/3 times area, which is 1/2 base times height. And for this triangle, it will be a 3. So using a centroid, this is the formula that you need to know. The area part should be really easy because you have circles and triangles and stuff. The height to the centroid, that may get a bit tricky, but not that much, and then W will just remain a constant. Yeah.
For the 1 plus 2/3, the 1 just come from the
Yeah, the 1 comes from the sea level height, and then you add how much to the centroid from the time. So different shapes have different places where the centroid is. Yeah. No, because they won't tell you where to find the centroid. Like that's what I'm saying. Like there is a place where the centroid is, but they're not gonna do that. And remember, this triangle could actually have been, if it was like this, the centroid is 1/3 from the base. So it'd be 1/3, so it'd be right here, okay? So this distance would be 2/3, all right? So we need to do 2 times 2/3 plus 1. If this triangle was drawn like this, the centroid is always 1/3 from the base, okay? Since the base is on the bottom, it's 1/3 higher. But the distance from the top is 2/3. So you need to do 2/3 times 2 to find this height plus 1, that gives you that.
That's just on one side of the track, right?
What do you mean one side?
That's just
Yeah, the
the
triangle is flat.
So can you assume that, both sides?
What do you mean both sides? It's just one triangle.
Think on both sides of the triangle, so block both sides, say two together on one side. It all come with opposite one side, if there's two sides, and then both sides.
No, it's always from like every which side.
Think about three-dimensional.
Oh, let's not go there. I can look at the homework problem, but yeah.
Sorry, we got 2/3 from on this problem here.
The 1/3 value is always from the base. Okay, so it's 1/3 higher from the base. You get the centroid value.
So you do 3 times 1/3, right?
What do you mean 3 times 1/3 or 2 times 1/3? Yeah.
Oh, okay.
But now we need to do 2 times 2/3 because that's from the top. Okay. You could have done 3 minus 1/3 or whatever. 3 minus 2/3. That would give you the same height value that you're looking for. Are you guys good with that? Let's do a circle quickly, but yeah. A centroid of a trapezoid? They're not gonna ask you that. Like, you know how we know 1/3? There is a way to find the centroid of a trapezoid, okay? And then there's other ways. But for a trapezoid, the best way would be to break it into triangles and squares and then add them up, okay? If you haven't signed in, please come sign in. But they won't give you a trapezoid. And I think, yeah, the center of a circle is just the very center. That's the centroid. The centroid method would just be going to the center again. I'll draw it quickly then, yeah. In that other problem that we did, they told you that the center was 10 distances away, right? The center is the centroid of a circle. So it will just be W, H times A. Your H value is equal to a 10. And then your area is pi r squared. So pi times 4 squared. So like that other integral that we couldn't solve, using the centroid method would be preferable because it works quicker. And they will tell you which to use when on the next exam. And when they say only use the centroid, use only the centroid method, or you'll get 0 points. Any other questions on this? Yeah. 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 Make sure you guys sign in if you haven't yet. Or you can just come. And that's pretty much what I have for you guys. For those of you that came late, do you guys want me to go over? Yeah. Actually, I'm going to go over the first few centroid problems, or hydrostatic. All right.
No,
So
not hers. Can I
who
just-
came late here?
Can I swipe this here?
So if you guys,
Does this work?
all right. I will go over what we did in the beginning. So that's pretty much it for those of you guys that came first.
I literally just handed you the same one 3 times or 2 times.
So which ones did I do?
All of them.
Okay, good. I'll delete the duplicates. So thanks for coming, but right now I'll go over the same thing again. Yeah.
When we did the triangle with the circle, you said L equals 2x, but x wasn't the radius.
Yeah. Just set
So
it L equals
if we,
2x.
but if we draw the picture,
I understand that, and
Yeah.
for the tomorrow I will ask her.
okay.
I will try to, or you guys can ask him tomorrow. Okay. Any third? Do you know the MRC, the Math Resource Center?
Yeah, I mean, like,
Besides from those, no,
okay.
because they have engineers there that can do this. And just to let you know, I will be in CP from 6 to 8 on the 4th floor today. Okay, the LLC tutoring thing. I will go over them, but do you have a quick question?
Yeah, it's like really quick. Super quick. All right. I don't understand why it's 5 square root of 2. Here's what I understand. So L is always going to be 5, right?
Because it's
This is really messy.
sine of theta
Is
equal to h divided by 5.
right,
Sine of theta is 1 over square root of 2.
which is the same thing as square root of 2 over 2.
Oh, this 5 is different. This square root of 2 dh is ds. This 5 is just L.
And then where does the square root of 2 come from?
Because that's what we found for ds.
Okay.
Sine of theta is equal to ds over dh.
So do you solve for dh and then plug that in?
You solve for ds and you substitute ds with dh. Because the original equation has ds in
Oh,
it.
ds.
Yeah.
Okay.
Okay, I'm going to go over the old problems. But if I am able to solve it.
Yeah, same thing.
But you will not have a problem like that on the exam. I remember that problem.
Is
Okay.
that, for, can I see it?
So, anyone else needs to sign in? Okay. Any other questions from the people who are leaving right now? Yes. Yeah.
Is there any way to hear this or why not?
I'm gonna put it online.
Yes, sir.
Yeah.
Okay.
This is one person's told me to split.
Looks like it's ready to go.
It's not the 3 units. Human split. You just do that like a normal trapezoid problem.
I like trying to show her like
You
what
have
my
to-
math error is.
Oh, your height value, since it comes from the bottom, it would be not like one way, it'd be the other. Like, you know how we have h minus 4 in this?
Yeah.
Because this is h minus 4. You need to do a method where it's from the bottom. So then your h value, it'd be 11 minus h.
Wait, so my H value would be what, like,
Your H value is from sea level down.
to
So-
the ball?
Your triangle is like that, right?
Yeah,
So then
it'd be that to all the way to the bottom.
this would be your H value. This is 11. So you're looking for this value, right? 11 minus.
Okay, so
All right, guys. So if you haven't signed in, come sign in, and I'll go through the problems again. To like 5:45. Okay. You guys can just sign in. So we have a triangle submerged. Always remember the formula. Remember this formula, guys, because in the end, it's always plugging the values in to get everything in terms of H. Okay? Make sure you guys sign. Is there supposed to be another class here? If you guys.
Yeah, we start at 5:30.
Oh, okay then. Who is here from the physics? Still. You guys? Okay. Since it's just the three of you, we can just go outside right now and then do it. Yeah. But yeah. Normally I'll try to redo the problems, and it'll be easier since it'll just like I'll have physical problems instead of teaching. Which